This is an AQA GCSE Physics exam, and this one is about energy analysis. Okay, it's question 11 on paper 1 of the specimens. It's a really tricky topic, and especially the way they've done things now. We're using energy as a way of doing calculations. It's about this conservation of energy, one type of energy transferring into another. Have a little read, have a little think about how you would actually approach these, so that maybe that you can be confirmed, or you know what you need to change about your approach once I go through them here. So whenever I read, I just go ahead and underline command words. We've just got to remember the equation which links gravitational field strength, gravitational potential energy, height and mass. Well, this is actually the equation that gravitational potential energy is mass times gravitational field strength times height. And you can write that in words, but I would just learn the algebra if I were you, because it's going to speed you up. It's perfectly fine. We really would like you to write an algebra if you're happy with that. Again, if you don't remember that, you're going to struggle with this one here. So, calculate the change in gravitational potential energy from the position where the student jumps to the point 20 meters below. That is not to the lowest point. They've told you very clearly the height you need to use is 20. Right, so let's find our data. We've already kind of worked out which one we're going to need to use. The mass is 50 kilograms. Gravitational field strength is 9.8. Now you need to remember that's 10. Most people remember at GCSE that's 10 or 9.81. Okay, is the kind of three significant figures value of that. But they've told you it's 9.8, so that's what we're going to use for this question now. The height, was 20, and that was given in the question. EP is 50, so the mass, times 9.8 times 20. And we're happy, they've given us the extra sig fig, which means we're going to give our answer to 3 sig figs as well. Each of the calculator, don't try and do these things in your head, will you? There's no such thing as a non-calculated physics exam. And in this case, no rounding necessary. Easy mark for remembering, mark for subbing them incorrectly, and mark for getting the right answer. We'll just check that we've used coherent units. Yeah, 50 kilograms, that's the SI unit. Newtons per kilogram, yes, that's absolutely fine. Meters, that's the SI unit for distance, so everything is okay there. Now you're told here 80% of the change in gravitational potential energy has been transferred to the student's kinetic energy store. So in other words, it's an 80% efficient jump here, okay, in terms of kinetic being the useful one. Don't really need to do that. This question, if it was in maths, is just 80% of 9,800, which I hope you're skilled enough to do that. Think about that as a decimal, 0.8 multiplied by 9,800, boom, 7840. And we're happy to give that to 3 sig figs because we know we were working to 3 sig figs earlier. Easy mark, thank you very much. Obviously, if you've done something wrong, this is what this means here, error carried forward. In the previous one, they will look that you can do 80% of whatever you've put in your previous one. Right, now calculate the speed after falling 20 meters. We're talking about the gravitational potential energy being transferred into kinetic. And we know now this is our amount of kinetic energy that we've got. So you need to remember the equation for kinetic energy. Okay, and the equation for kinetic energy is EK equals a half mv squared, where v is the speed, and that's the target we're after. What about mass? Do we know the mass? Well, yes, the mass is the same as in the previous question, and if you look back, it was 50 kilograms. So the kinetic energy, we're not going to use the 100% of the GPE, we're going to use the value from above. Next thing to do is to rearrange this, okay? We want V, so we need to rearrange for V. You can, if you struggle with rearranging, you can just input the numbers. And if you just input the numbers here, you will actually get yourself a mark. So it's always worth doing that. If you're struggling to rearrange, just putting the numbers in shows the examiner that you know which bit is which. But I'm going to do the rearranging because it's not that tricky. Okay, so 2ek, that's multiplied by both sides by 2, is mv squared. 2ek over m is v squared. So v is the root of 2ek over m. Now actually, I always just suggest to my students that they just remember that rearrange form, because although this is not that challenging, you might make a mistake. You might get your 2 in the wrong place. And just remembering it is going to save you that little bit of time. And when you're under pressure in the exam, that's when we make mistakes. Now I'm going to sub my numbers in. Then I'm going to reach for my calculator, being careful to use the brackets or the fraction function correctly. And the beauty of these calculators, if we learn to use them correctly, is we can check that once we've pressed the equals button. And the answer is 17.7 meters per second. Now we're going to go through and think, well, have we got all 4 marks? Well, yeah, okay, I think I've got the right data. I've rearranged and inputted 17.7. Yep, that's fine. But look, there's another command word in the question. Give your answer to 2 significant figures. So they're checking, can I rearrange and can I use significant figures? Because we use sig fig in physics rather than decimal places. The final mark is 18 meters per second. Don't need to check my units because they've given me one there. There was no mark for the unit. So what's next? We need to calculate the spring constant of the bungee cord. At the lowest point of the jump, the energy stored by the stretched bungee cord is 24.5 kilojoules. So that is my elastic potential energy. And because it says kilojoules, I'm just going to do the smart thing and convert that into SI straight away. The bungee cord behaves like a spring, so I can use my equations for Hooke's law. And if I look on the physics equation sheet, the equation is elastic potential energy is 1/2 times the spring constant times the extension squared. So I need to know the extension as well. So do I have an extension? Let's go back to the stem of the question and see if we can work out the extension. We're talking about the stretched bungee cord. Here's the bungee cord, and then there's the 20-meter length there. They tell you the bungee cord has an unstretched length of 20 meters, and the lowest point is 55.0. So the extension of the bungee cord is 35.0 meters. Okay, I hope that makes sense. That's a bit of data that's quite buried within the stem of the question. But delta x, the extension, is 35 meters. So now I've got all the data that I need to do. I want to work out k, so again I can rearrange before I do anything, but I can get myself a mark just by substituting in. Okay, so if that's an easier method for you, then go ahead and do that. So I'm going to times both sides by 2. I want k, so I don't need to do any funny rooting. So k equals 2 times the elastic strain energy divided by delta x squared. Now I can input in my data, being careful to multiply by 2. I've almost forgotten that twice on this little question. Now I can reach for my calculator, and again, using the full functionality of the calculator means that I'll be able to review that. It's the same exactly as that, including all the zeros, including the square, before I go ahead and press the equals sign. Now I'm just going to check, have I used SI units? Yes, I converted from kilojoules. Yes, this is meters. 40 seems like a sensible answer to me. So if you think about that in terms of, is that sensible? 40 newtons for every meter, so 4 kilograms would extend the spring by a meter, extend the rope by a meter. That seems to make about some level of sense. It's not massively too big or massively too small from what I would expect. They say an answer of 16.2 gives 2 marks, and I think that's if you accidentally use 55 rather than 35 as your extension. In this case, there's a mark for recognizing the extension is 35 and for converting the energy from kilojoules. So you need to do both of those. There's a mark for getting the data in the right place, and then there's a mark for 40. It's been Gorilla Physics. I hope that's been really useful to you. We're all about understanding your physics more, so you enjoy it more, so you get more confident, and then you will do better in your exams.